Hey honors, we're talking about quadratic word problems today. We also talked a little bit more about like simplifying radicals and stuff like that. So let's jump into one of the word problems that I left you for homework and kind of review some of the things we talked about with the other ones. So one thing you should pay close attention to is the fact that the C value is always the y-intercept. So if you notice in both of these first problems, that C value is always the value that you're starting with on the y-axis. So for this one, what I notice is I have A and I have B, and the reason why I know that's B is because T is to the first power. It's AX squared, BX. X is linear in this case, and T is the linear term. And so the C value is kind of missing. So that means for this one, you better start at the origin. If you notice in the problem, it says an object is launched from the ground. So there's not a platform, you're not off the ground at all. In fact, it's just starting right from the height of 0. So then it's launched up, it comes back down. And so we have to find a lot of times a few different things. What is its max height? What time does it take to obtain that max height? And so both of those first questions are essentially asking what is the maximum point, what is its x and y value. Now you think about the problem, t is the variable, so time is the x. And so when I'm asking a question about how long or when, okay, that's the question about the x value of the vertex. And it says that it calculates height, and so in terms of your output, your y value represents the height at that time. And so this particular point's important too, because this is when it equals 0. That's when the height is 0. And when it equals 0, that's when the ground has occurred, when it hits the ground. Okay? So let's do one thing at a time. When I'm trying to find something, when I'm trying to find the max point rather in something that is in standard form, that's when we need to do negative b divided by 2a. So negative b in this problem, negative 39.2. 2a, 2 times negative 4.9. So negative 39.2 divided by negative 9.8. So I may want to use a calculator there if I'm not really confident doing that, which I am confident doing it, but I'm just modeling how I would do it at home if I were you. Negative 39.2, sorry, not 8. And we're dividing that by negative 9.8. So that gives me 4, which is great. So that means that the x value is 4. So in question, in part B, the question is when will it obtain this height? So the answer to this first part is 4 seconds. So in 4 seconds, it's going to reach that max height. Sorry, having trouble writing. 4 seconds. But what is that max height? What would happen if you plugged in 4 for the time? So because I do have a graphing calculator handy to me, I have it graphed in y equals. I went ahead and typed in this equation to make this part a little simpler. And then I'm going to hit trace. So you can kind of see that U upside down. It's going almost right up through the y-axis, but not exactly, and it's coming back down. And so I'm going to spend some time going to the window here. And I really don't care about time being negative. So the smallest I want the x values to be is 0. And 10 seems fine since I saw it actually come down when we traced it. Now I don't care about it going below the ground, but I really don't know how high it goes. I may not need a ton. Let's just start with like 50. And I still don't see the top of that, so I may change the 50 to maybe 100. And now I see exactly what I want. Now, because we already did negative b over 2a, I can put in 4, and I see that max height is at 78.4. Okay? Which means in 4 seconds, it'll reach its max height of 78.4, and in this problem, it's meters. Okay? So this is your maximum. 4 seconds to reach 78.4. Now this part is more about what makes it equal 0. So I gave you guys a nice hint. If you have a graphing calculator, you can kind of see if it hits a nice value. So 6 makes 58, 7 makes 34, 8 makes 0. So that saves me from having to do the quadratic formula, and this is 8 seconds. In 8 seconds, you get 0 meters for the height. So if you wanted to use the quadratic formula, you could. If you didn't have a graphing calculator, using the quadratic formula would yield 8 as an answer. So that's what they really want you to do if you don't have a graphing calculator, but when we do, that's the easiest way to do it. Okay. All right, so let's talk about simplifying non-perfect squares using perfect squares. So for example, this first one, if I want to break this up, thinking about two numbers that are perfect squares, and I want the biggest one here that multiplies to be 128, I'm thinking about 64 times 2. So the square root of 64 is 8, and then you're left with the square root of 2. 200, so that would be 100 times 2, and the square root of 100 is 10. 10 square root of 2. So you can try 3 and 4, and let me show you some that have exponents. So the square root of 200, again, we just talked about that one, because that would be 100 times 2. And because this exponent is even, I don't really want to change that because I can divide that number easily by 2, and that's how you square root variables. So the square root of 100 is 10, and divide 16 by 2, that would be b to the 8th power. If you think about it, b to the 8th times b to the 8th is b to the 16th because the powers add. That's why you divide by 2. And then the square root of 2, you really couldn't do anything with it. Now, odds are a little harder. That would have to break up, kind of like 50 breaks up with 25 times 2 to be 50. I want to go down to the nearest 1 below it. So that'd be x to the 8 and then an extra x. And so this allows me to take as much as I can when I divide by 2. You just have a remainder. So the square root of 25 is 5. Divide 8 by 2, that'd be x to the 4th. And then the square root of 2x kind of goes back together. So let's try 32. I think that was throwing some of my other classes off when we did that one. 32a, so this is the square root of 16 times the square root of 2. And then the square root of a, that's already so low that I can't divide it by 2, and I can't go down 1 because that'd be 0. So I'm just going to deal with the 32 and put these back together. So that's that. Try some of the other ones and come in class tomorrow and we'll talk about any questions you have. Remember how to solve using factoring. That's a huge part of the next test, I think. So factor that and then eventually tell me what makes each value 0. So whenever you're solving, your goal is to say what the value of the variable should equal that makes it 0. Now in this case, it's not equal to 0, so you're not really ready to start the formula if you're using the quadratic formula, or in this case, factoring. So make sure you move that number over and then think about what multiplies and adds, and then the last part is what makes each of those 0. Taking square roots, this is when you have no b term. When b is missing, you can kind of do the problem a little quicker. So I'll do 14, I'll let you mess with 13. Let's subtract 1. 6m squared equals 534. Divide this by 6. And just to make this easy on my brain, 534 divided by 6 makes 89. Now, 89 is not a perfect square, and I'm not sure that that's going to simplify, so that may just be my answer, plus or minus the square root of 89. I mean, you could round it if you want, put it in the calculator and round it the 10th or the 100th or whatever, but this is really an exact answer. This is perfect. It doesn't break up like you're doing in the top part of this worksheet, but if that does occur, you're looking to do that when you see it. So let's do the quadratic formula. I'll let you try 15. and I'll work with 16. So I noticed that this is not equal to 0, and I need all the terms on one side. So the first thing I want to do is subtract 2x from the right to the left, and also I'm going to subtract 14 so that everything is on one side and you get equal to 0. So, sorry, lost my, too far. So negative b would be positive 2. We have negative 2 squared, 4 times 7 times negative 14, and then I'm going to divide all of that by 2a. And in this problem, 2a would be 2 times 7. So 2 plus or minus, I'm dividing by 14. And so let's see what negative 2 squared minus 4 times 7 and all that would give you. So we've got negative 2 squared. Very important that you put that in parentheses if you're going to let the calculator do all that for you. Putting in a 7, and then I'll also need negative 14. So it looks like my discriminant value is 396. So I am trying to show how to simplify radicals with this. So I'm going to take 396 and see if any numbers that are perfect squares go into it. So I'm going to try 64. Let's see, 396 divided by 16. No. Well, see, I know 4 goes into it. I'm just seeing if any other numbers go in. Now, this is interesting. 4 times 99 is 396, but 99 has a perfect square in it, and that'd be 9. So I'm wondering if 36 goes into it. 396 divided by 36, and see, that'd be 11. So I'm going to say that this is the square root of 36 times 11, and that number changes to 6 square root of 11. So this should be 2 plus or minus 6 square root of 11 all over 14. And because these numbers all share a common factor, I'm going to divide them all by 2. So that gives you 1 plus or minus 3 square root of 11 all over 7. And this is the best answer for you guys. So I'll check the homework tomorrow. Thank you so much for watching, and I'll see you then.